97%. That is how much of the observable universe has already left us permanently. Not in a billion years, not when the last star dies. Right now, tonight, while you watch. Most people assume the universe is vast and waiting. 2 trillion galaxies, 46 billion light-years in every direction, available to future civilizations with better technology and more time. That assumption is wrong. The universe is leaving us. Galaxies are crossing a physical boundary built into the structure of space itself, a point of no return from which no signal, not even light, will ever return. We can still see almost all of it, but almost none of it belongs to our future. The observable universe contains approximately 2 trillion galaxies. For most of human history, we had no reason to doubt that those galaxies, however unreachable in our lifetimes, would at least remain available to the future, held in place by the same physics that had always governed the cosmos. That sense of stability rested on an assumption so fundamental that almost nobody questioned it. Then a measurement came in that shattered it, and with it, everything we thought we understood about what the universe was actually doing. The universe has been expanding since the Big Bang, approximately 13.8 billion years ago. That expansion has been understood since the 1920s, when astronomer Edwin Hubble confirmed that distant galaxies are moving away from us, and that the farther away they are, the faster they recede. Not because the galaxies are flying through space, because space itself is stretching. For most of the 20th century, physicists assumed one thing about that stretching. It was decelerating. The Big Bang had launched the universe outward with enormous force, and gravity, the collective pull of all the matter inside it, was doing what gravity always does, pulling back, slowing the rush. Eventually, most models predicted the expansion would stop, possibly reverse, and everything would collapse inward. Nobody was prepared for what 2 independent teams of astronomers discovered in 1998. They were studying a specific type of stellar explosion called a Type 1a supernova. These explosions are remarkably consistent. They always reach roughly the same peak brightness, making them reliable as cosmic distance markers. By measuring how bright a supernova appears from Earth versus how bright it actually is, astronomers can calculate exactly how far away it is, and therefore how fast the universe was expanding at that moment in history. What they measured contradicted everything. The supernovae were fainter than they should have been, not slightly, but measurably, consistently. 2 separate teams, Saul Perlmutter's Supernova Cosmology Project and Brian Schmidt and Adam Rees's High-Z Supernova Search Team, found the same impossible result independently, ruling out instrument error. The distant supernovae were further away than they had any right to be. The universe was not slowing down. It was accelerating. Something was actively pushing the expansion faster. Something that fills all of space, exerts a repulsive force that overpowers gravity at the largest scales, and leaves no trace that any instrument has yet detected directly. Cosmologists named it dark energy. Dark energy is not matter. It does not interact with light. Nothing we have built can measure it except through its effect on the expansion itself. Yet calculations place it at approximately 68% of everything that makes up the universe, more than double all matter combined. It is the dominant force, shaping everything that exists. The most abundant thing in the universe is completely unknown to science. In 2011, Perlmutter, Schmidt, and Rees received the Nobel Prize in Physics for the discovery. The Nobel Committee described dark energy as, and these are their exact words, perhaps the greatest enigma in physics. As of June 2026, a major challenge to the dark energy model published in late 2025 has been formally overturned by a team including both Nobel laureates, published in the monthly notices of the Royal Astronomical Society. The universe is still accelerating. The measurements are confirmed. Most people picture the observable universe as a place where everything they can see is, in principle, reachable. A vast sphere of 2 trillion galaxies, 46 billion light-years in every direction, waiting, in theory, to be explored. That picture is wrong in a way that changes everything. There are two different boundaries around Earth. The gap between them is the departure. The first boundary is the observable horizon, the edge of everything whose light has had time to reach us since the Big Bang. That sits at approximately 46 billion light-years. Within it, roughly 2 trillion galaxies. The second boundary is the cosmic event horizon. This is the maximum distance from which light emitted today can ever reach us in the future, given that dark energy is continuously accelerating the space between us and everything else. That boundary sits at approximately 16 billion light-years, less than half the radius of what we can observe. Everything beyond the event horizon is already severed, not difficult to reach, not reachable with better technology in a million years, already severed. The light we currently see from those galaxies is ancient. It left them billions of years ago before they crossed the boundary. The galaxies themselves are already gone from our reachable universe, accelerating away faster than any signal we could ever send. Space itself is stretching. As it stretches, it carries light traveling through it into longer, redder wavelengths, the way a sound drops in pitch as its source moves away. This effect is called redshift, and astronomers measure it with a single number. Research by astrophysicists Tamara Davis and Charles Lineweaver identified a critical threshold. When a galaxy's redshift reaches 1.8, it is being carried away faster than any signal we could ever send, even at the speed of light. Those galaxies are crossing our cosmic event horizon right now. 97% of all galaxies in the observable universe are already beyond our permanent reach. The universe is not shrinking, it is leaving. We can still see 97% of it. We will never reach any of it. The trajectory has been modeled in detail. Within approximately 30 billion years, roughly twice the current age of the universe, large-scale cosmic structure will freeze. The vast web of galaxy filaments that defines the observable universe today will stop evolving. The local group, our cluster of roughly 50 galaxies, including the Milky Way and Andromeda, will become a permanent island. Every galaxy outside it will have receded beyond the event horizon, forever. A 2018 paper from Fermi National Accelerator Laboratory calculated that within approximately 100 billion years, all stars beyond the local group will have fallen beyond the cosmic horizon. Not merely unobservable, entirely inaccessible. The energy they produce, the light they carry, the information they contain, unreachable as completely as if they had never existed. What remains after that is a single merged galaxy, the result of the Milky Way and Andromeda colliding over the next few billion years, alone in an expanding, darkening void. No neighbors, no incoming signals, no evidence visible to any observer inside that galaxy that the universe ever contained anything else. A future astronomer in that galaxy would look outward in every direction and see darkness, not because the universe ended, because everything beyond the horizon is gone forever. The universe is not heading toward emptiness. It has already begun the process of leaving us behind. We did not arrive too late to see the universe. We arrived just in time to watch it disappear around us. We will not go dark. We will go alone. Here is what all of it adds up to. The universe contains 2 trillion galaxies. The force pulling them away, dark energy, makes up 68% of everything that exists. It was confirmed by 2 independent teams in 1998. It earned the Nobel Prize in 2011. As of 2026, it is confirmed still accelerating. As of 2026, its nature remains the greatest unsolved problem in all of physics. 97% of those 2 trillion galaxies are already beyond permanent reach. Not eventually, tonight. The departure is not coming. It is ongoing. Every second, more of the universe crosses the line from which no signal can ever return. What will always remain is the local group, the Milky Way and Andromeda and the smaller galaxies bound to them by gravity. An island. Everything outside that island is leaving. Dark energy ensures it never comes back. The universe has been departing since before Earth existed. By the time any civilization is advanced enough to want to follow, the distance will be physically, permanently, mathematically impossible to close. Right at the start of this video, you saw galaxies crossing a threshold and vanishing. That was not an animation. That is what is happening in every direction tonight. It will not announce its departure. It will simply no longer be there. 97% gone, and it is still leaving.